So where we left off last time was talking about Java virtual threads versus Java platform threads. And I kind of described the difference between a platform thread and a virtual thread. Remember, a platform thread actually has address information like a runtime stack that takes up a fair amount of space, whereas a virtual thread is multiplexed on top of a small number of platform threads and uses much less state, so it's much more efficient. So we're now going to talk about how to create Java platform threads and Java virtual threads. And we'll talk about some of the best practices when applying virtual threads in practice. So there's a couple of different ways to create Java platform threads. One is the traditional way, which is to do nothing different from what you've done if you've been programming in Java for the last 25 years. And all you do is you could, for example, extend the thread class, override the run method, then you make yourself a new instance of that subclass, and you start it. So that's the good old way of making a thread, one of the good old ways of making a thread. Another way to do it is to implement the runnable interface, override the run method, make an instance of that runnable, and then go ahead and pass the runnable to the constructor of thread and start it. So that's another way to create a classic Java thread. The downside with these Java classic threads are they're relatively heavyweight. They take up all that address space. The Java 19 way of doing this initially is exactly like the way it was before. So you can use the old stuff if you want to. If you liked your old way of making platform threads, you can keep your old way of making platform threads. So by default, a traditional Java thread is a platform thread now. However, there's also some new APIs that allow you to be able to make a platform thread in a more incremental way. So one way to do that is to say thread.ofPlatform, which says make a platform thread, and then you can say start that thread running this runnable. So that's one way to do it. Another way to do it is you can make yourself a platform thread by saying thread of platform unstarted and give it the runnable. That will not start the thread, and then later, ... after you've done some other initialization or whatnot, then you can go ahead and start the thread. So that's a way to kind of separate the creation of the thread from the starting of the thread, the platform thread. But Java platform threads are relatively heavyweight. So for that reason, Java virtual threads are now available in modern Java, really modern Java, as we call it. And there's a couple ways to start them. One way to start a virtual thread is to say thread.startVirtualThread, and then you give it a runnable. And it'll go ahead and create and start a virtual thread that will run the runnable. That's a very straightforward way to do it. Another way to do it, which mirrors what we just saw with platform threads, is to say thread.ofVirtual. So you make a virtual thread, and then start that running the runnable. That's a little bit more verbosity, but you'll see why it's useful. The reason it's useful is you can say thread.ofVirtualThread.unstarted and give it the runnable. And once again, you have yourself now an instance of a non-started Java virtual thread, which you can do some other initialization, ... and then go ahead and start that unstarted thread. So you can see there's a bunch of different ways to do this. And the nice thing about Java virtual threads is they're relatively lightweight. So you can have oodles of them. And we will see an example of creating oodles of Java virtual threads here momentarily. So let's talk a little bit about some best practices to apply when you use Java virtual threads. So some of the things to think about are talked about in this article, so I recommend you take a look at this. It lists a bunch of best practices for using virtual threads. Probably the most important one to remember is do not pool virtual threads. In traditional Java threads, which were fairly heavyweight to start, people would often amortize the creation costs by creating a pool of them, typically about the number of cores as there were on the CPU. And then those threads would be pre-started. They would wait in so-called hungry puppy fashion for requests to come in and be put onto a synchronized queue. And then as requests were put on the queue, threads that were in the pool would wake up and process them, process the events that were on the queue. That is no longer necessary with virtual threads. So creating virtual threads is really fast, so there's really never, ever, ever a need to pool them. In fact, it kind of defeats the whole point of a virtual thread. So don't have a pool of virtual threads. Another thing to think about, and this is a bit esoteric, but there was this concept in Java, there still is a concept in Java called thread local variables. And thread local variables allow you to be able to have so-called thread-specific storage or thread local storage, such that each thread will have its own instance of some field, but all the threads think of that field in a common way. If you're ever familiar with the C or C++ concept of error no, that's something that typically is implemented by thread-specific storage in modern versions of Unix and Windows and so on. So if you're using virtual threads, don't use thread local variables because it'll make lots of instances of thread local state, which are a lot of extra overhead and probably not what you want to do in this case. And then the last one, which is also very important and requires you to kind of learn a few other modern Java concepts or features, is do not use synchronized blocks, synchronized methods, synchronized statements, and so on. Instead, if you need synchronization, replace the use of the synchronized keyword with a reentrant lock or a stamped lock or some other type of lightweight synchronizer. And the reason for this is that the underlying Java execution environment, typically known as the Java virtual machine in most cases, doesn't really have good support yet for dealing with synchronized blocks. So the synchronized blocks will actually, the use of synchronized blocks will pin virtual threads to the underlying platform thread, thereby making things less scalable than you might otherwise have. So if you stick with reentrant locks, the Java execution environment knows how to deal with those, and so it can avoid pinning things unnecessarily. Perhaps at some point, the Java execution environments will be improved, so this will no longer be an issue, but for right now, stay away from synchronized. It's probably a good idea to stay away from synchronized in general, because synchronized is limited relative to reentrant lock or stamped lock. And so you're better off learning these newer patterns and newer mechanisms anyway. And if you're ever curious about that, I have another course, all of which videos are available on my website, which talks about Java synchronizers, and it covers reentrant locks and stamped locks and all that good stuff. So you can take a look there if you need a refresher on how to use reentrant locks. So that's the end of the overview, another overview of Java platform threads versus virtual threads, focusing primarily on how to program them, how to code them to start them up.